All right, this is the second part of the notes for combinations of functions. Last time we did all this. Today, we're only going to go over one topic, but it does tend to confuse students quite a bit. So we're going to do quite a few of them. All right, so we're going to focus all six on the same concept, which is composition of functions. So here's what here's what we're going to focus on today. I know it looks like fog of x, right? But that really says f after g of x. This little circle, you can think of that as the word after. So f after g of x or f composed with g of x. Both ways are read. You also hear f of g of x. There's like three different ways. So f after g of x, f of g of x, or f composed with g of x. All three of them are the same. I like to say f after g of x, just because it makes me think like, oh, g of x needs to go first. All right. So f after g of x is equal to f of g of x. That's what we're going to be working on today. We're basically sticking one function inside the other. All right. So here we have three functions. It says let f of x equal to x plus 7, g of x equal to 4x minus 1, and h of x equal to x squared minus 2. I want to find h after f of 2, g after h of 3. So what the heck are they asking us to do? Well, first, let's color code these things to make it a little bit easier for us to reference. I'm going to make f of x green. I'm going to make g of x pink. And I'm going to make h of x yellow. You can pick any colors you want. Just make sure that you keep consistent with whatever you have. All right. So the first one says find h after f of 2. And you're going, well, what the heck does that mean? Well, let's go ahead and write what the definition says. It says if I have it in this order, f after g of x, then you can write these within each other. I'm going to take the f function on the outside. The g function goes on the inside. Keep it in the same order. So this one, the first one stays outside. This one stays inside. So if I'm going to do that here, h after f of 2, what I'm going to write it is going to be, man, I said a lot. What I'm going to write it as is going to be like this. I'm going to write this as h of f of 2. Or it says, hey, take h after you've done f of 2. So what I need to do first is I need to find f of 2. Right? Figure out what f of 2 is first, then you can mess around with h, okay? Because again, you have parentheses within parentheses. You need to do the inside part first. So first, I need to find f of 2. If I would have told you earlier, like, how do you find f of 2? You're going to say, oh, easy. Just take your 2, plug it into your f function. And my f function is in green. So I'm going to take 2, and I'm going to plug it into the green function. That f of 2 ends up being h of, remember, when I take 2 and I plug it into my f function, that's me taking the 2 and plugging it in right here. So it's going to be written as 2 plus 7. This is coming from my green function, okay? 2 plus 7 is just 9. So I get to write this as h of 9. So now that I'm done with the green function, now it says take h of 9. Well, what's h of 9? H is my yellow function. What this is saying is, hey, now that you got this number 9, that 2 magically turned into a 9. Now that you have this number 9, I'm going to take 9 and I'm going to plug it into my h function, which means that 9 needs to go right there. H of 9 is the same thing as 9 squared minus 2. This is coming from my yellow function. 9 squared is 81. 81 minus 2, that gives me 79. And I am done with the first problem. So composition of functions are kind of weird because you got to stick a function inside another function, okay? Now, when they have the numbers on it, honestly, it's not too bad because it's kind of easy to keep track of numbers. Later on, when they don't give you numbers, that's where we're going to really run into a couple things. But let's worry about that later, okay? Let's first focus on just how this thing runs. So I want to do g after h of 3. G after H of 3, according to my rule, that's the same thing as, remember, you keep it in the same order. So G on the outside, H on the inside of my value 3. You keep it in the same order going from left to right. Now, the only thing there, though, is you have to do the stuff inside the parentheses first, right? So first, I need to find H of 3. H of 3, well, the H is my yellow function. So I need to take 3 and I need to plug it into my yellow function, which means I need to write it right here. So this is going to be G of, and H of 3 would be 3 squared minus 2. That's coming from my yellow function. That's me taking the 3, plugging it into my yellow function and seeing what I get, okay? Let's see, 3 squared is 9, and then 9 minus 2 is 7. So this becomes G of 7. Now, G of 7, that's my pink function. So I'm going to take my 7, and this is saying take 7 and plug it into your pink function, which means I'm going to plug it in right here. So this G of 7 now turns into 4 times 7 minus 1. 4 times 7 is 28. 28 minus 1 is 27. And I am done. I know that G after H of 3 is 27. You know what? I didn't write that on the last one, so let me write H after F of 2 is equal to 79. And then G after H of 3 is equal to 27. What that's saying is if I take 3 and plug it into my H function and then I plug it into my G function, the answer I'm going to get is 27. Okay. All right, I want you to go ahead and try this one on your own. I know it looks like fog, but that doesn't say fog. That says F after G of 3. Okay. F after G of 3. Go ahead and press pause on the video and see what you get. I'm going to assume that you already did that. F after G of 3, what that really means is F of G of 3. G of 3, that's my pink function if I work from the inside out. So first, I need to take G 3 and plug it into my G function. What I end up with is F of, let's see, G of 3, I'm going to take 4 times parentheses 3 minus 1. That's me taking that 3 and plugging it into my pink function. 4 times 3 is 12. 12 minus 1 is 11. So this becomes F of parentheses 11. Now, the F function, that's my green function. And that says take 11 and plug it into my green function. Well, that would be 11 plus 7 if I plugged it into my green function. And then 11 plus 7 is just 18. So this is telling me that if I take F after G of 3, then the answer I get is 18. All right, so hopefully you get a good idea of what it means to have composition of functions. That means you run with one function, you plug it into the other, okay? Here, though, they are doing the same thing, but this time they're not telling us like what the number is. They say, no, we want you to leave it with the value of x. So this gets a little harder for students because you're going to be plugging in entire functions, not just a singular number. So let's do the first part. I'm pretty sure the first part you're going to be fine with. I'm going to do the exact same thing I did before, which is I'm going to label each function with a color. Here's my green function. Here's my pink function. And here's my yellow function. I want to know what's f after g of x. So we are going to stick the g function into the f function. I'll show you what that means I'll show you why that is what it is in a little bit. Remember that f after g of x really means f of g of, and in this case, we're going to keep it as x. The first thing we're going to need to do is we're going to need to figure out what is g of x. G of x is my pink function. So instead of writing g of x, normally I would plug in a number into my pink function, but there's no number to plug in. So instead of doing that, I'm actually going to write down what g of x is. G of x is this 2x minus 3 right here. Do you see that? Okay. So instead of writing g of x, I'm going to replace that pink stuff inside the parentheses inside here I'm going to replace it with the 2x minus 3. So instead of writing f of g of x, I'm going to write f of, what did we say g of x was? We said that g of x was 2x minus 3. All I did was I replaced it with the pink portion. I know that g of x is the same thing as 2x minus 3. So here's g of x. It's the same thing as 2x minus 3. I replaced it. I substituted it, okay? That part, honestly, for the most part, students are okay with. They usually don't have a problem with that, okay? Where they do have a problem with is this next part right here. Now, what am I going to do? I am going to take that 2x minus 3, and it says I need to take that 2x minus 3 and plug it into my green function. So I'm going to take 2x minus 3 and plug it into my green function. I'm going to do this a little bit different. Take that 2x minus 3, which is in pink, and plug it into my green function, which means anywhere I see an x, I get to replace it. So you see this? I'm going to replace this, which means it's going to go right here. What's going to go right here? The 2x minus 3. The 2x minus 3 is going to get replaced right there because I'm replacing it into my green function, right? Before, if this would have been like f of 4, you would have taken the 4, you would have plugged the 4 right here. Oh, 3 times 4 is 2. But you don't have a 4. You have a 2x minus 3. That means you're going to take the 2x minus 3 and you're going to place it right there. What is that going to look like? Well, this is going to be a 3 times whatever I replace it with in pink. In fact, let me put a little pink dot for right now. In pink, 3 parentheses, all that in pink, minus 2. So this is going to be 3 parentheses, all that pink stuff, 2x minus 3, and then I need to finish up, right? 3 parentheses pink minus 2, like that. What the heck is going on? Well, it looks like what's going on is I need to distribute that 3, so I'm going to go ahead and distribute the 3 right now. That's going to be a 3 times 2x, which is 6x. 3 times negative 3, that's going to be a negative 9, minus 2. And I can combine like terms, and I get to say that 6x minus 11 is my composition of the function. That is f after g of x is equal to 6x minus 11. What that's saying, guys, is if I take the pink function and plug it into my green function, if I do the composition, I can jump straight to this function right here. It's just going to be 6x minus 11. Okay. In fact, you know what? If I would have said f after g of 4, we just did that above, right? Like f after g of 3, okay? Well, this bypasses that. All I have to do is plug in the 3 right here. 6 times 3 is 18. 18 minus 11, done. Okay, it does the shortcut formula of it. It already has both the functions combined. All right, let's try it again. I know that I lost a lot of you guys, and this is just going to get better with practice. So let's try it again. Let's run through the process. H after g of x, I know that you guys are probably pretty good at saying, well, that's the same thing as h of g of x. Most of the time, that's pretty good. Second part is like, all right, well, let's start in the inside. What do I see on the inside? On the inside, I see a g of x. So I think a lot of you guys are going to say, all right, well, the g of x is just 2x minus 3. So I'm going to take that 2x minus 3 and I'm going to plug it in right there. I think most students are pretty good with that. They say h of 2x minus 3. And then this is the part where they go, wait, what? What do I do now? Well, because it's not a number, right? If it would have been h of 7, it would be really easy. H of 7, you just take the 7, plug it in here. That's h of 7, which means I plug it in here. You plug in the 7 right there. You don't have a 7. You have a 2x minus 3, which means that 2x minus 3 is going to go right where that x is at. It's going to go right there. Okay, so I'm going to write parentheses 2x minus 3. That's the pink stuff right here. What am I doing with this thing? Well, I need to square it, and then I need to subtract 3. So I need to square this thing, and then I need to subtract 3. All right, this is going to be a lot more work because that 2x minus 3, you're going to write this as 2x minus 3 times 2x minus 3 minus 3. All right, and what is that forcing you to do? That's forcing you to distribute, right? So this is going to be 4x squared minus 6x minus 6x plus 9 minus 3. And then you combine like terms, that's going to give you 4x squared minus 12x plus 6. What the heck is 4x squared minus 12x plus 6? That's going to be your h after g of x is equal to this function now, okay? This is a composition of functions. This is us putting the two functions together. Very, very important for you to know that h after g of x is not the same thing as g after h of x. If you switch these around, you will get a different formula to pop out over here, okay? So just because you found one doesn't mean you found both, all right? All right, now that you've seen it twice, hopefully that's a little bit better for you. And I just realized I didn't highlight this in yellow. This is my yellow function. I would have plugged it into the yellow function, which I did, okay? Go ahead and try it yourself. We want you to do g after f of x. Press pause on the video, take a crack at it. I'm going to assume that you already did it. So I'm going to go ahead and start jumping into this. Let's see. G after f of x, that's g of f of x. All right, on the inside, I have f of x. F of x is my green function. So f of x is 3x minus 2. So I'm going to write this as g of 3x minus 2. I think for the most part, most students are pretty good with that. That says take the 3x minus 2 and plug it into your green function. I'm sorry, my g function. My g function is the pink one. So I need to take that 3x minus 2 and I need to plug it into my pink one, which means I need to plug it in right here. That's where the 3x minus 2 is going to go into. So I'm going to write this as 2 times parentheses 3x minus 2 minus 3. That's me taking my 3x minus 2 and plugging it in right in there for that x, okay, because I'm plugging it into my pink function. All right, what do I end up with? I end up with 6x minus 4 minus 3, which is 6x minus 7. That is my g after f of x. And we are done. All right, guys, that's all the notes for today. Hopefully that made sense. If you have any questions, please feel free to ask.